in this video we are going to discussing one topic which is very important in DBMS, that is a canonical form. First of all, we are starting with what does the meaning of a canonical form. So basically it says that it is a minimal cover of the functional dependency. That means here we have a three functional dependency, and as we see that in this functional dependency in LHS there are two attributes which can be creates a redundancy, and in the right hand side we can also see that there are two attributes. It also be creating a redundancy in a table. In canonical form we are trying to minimize the dependencies of two attributes. Basically we want to remove the redundancy of an element from functional dependency. That's our aim. What we have to perform, what we have to take the step to remove the dependencies that we are discussing in this video. First of all, we have to start with the decomposition rule. In decompositions, first of all, we will find the functional dependency with the help of their its own FD. Here we have three functional dependency: x derived y, and wz derived xy, and y derived wxyz. So first step is try to decompose the functional dependency in further part. In functional dependency 1, x derived w, in left hand side there is one element, and of course in the right hand side there is also one element. So here's no any case will be arise in future of any duplicacy. In a second functional dependency we have wz's, and it's derived x and y. So wz's together derives xy. We can write wz derive x and wz derive y. This is the approach of writing this functional dependency. Here wz derives xy, we can write individually that wz derived x and wz derived y. And similarly with y functional dependency, its derived three attribute, we can separate it out. Okay, now the decomposition part is done. Now we are trying to finding the functional dependency of each. We are trying to finding the closure of each attributes of this dependency, and we are keeping that elements of that attributes, those who have their essential in future need. So let's start with x closure. So from x closure we get x, and x derive y, so we get y and w also. Now we will finding FD without x closure. When we writing again the closure of x, but this time we ignore this, right? So the x, it's the x का खुद का तो x ही होता है, और anything else which we derive x, no. Here we can clearly see that without FD and with FD we can't get output same at the end. With functional dependency x close, we get closure xw. Without functional dependency 1 we get only x. So the presence and absence of this dependency give effect in our result. That's why we can say that it is an essential attributes, so we don't need to remove it. Now we are going for checking the step functional dependency 2. So we firstly find the closure of wz. What we get? Wz, from wz we get itself wz, then wz derive x, and of course wz's derive y. So here we get all the relations of the table. Again we are finding the closure, but in this time we are escaping this functional dependency. Then we will find from wz we can write wz itself, and again if we hidden this functional dependency, again we can absorb another wz derives y. We can write wz y and y derives z. So in this time we can see the presence and absence of the functional dependency does not affect the result. So this time we can eliminate this redundancy at the same time, and further checking we can't take this functional dependency, because now we are deleting this functional dependency from our database. Now we are going to checking the wz. So with wz functional dependency we will get wzyx, and now we are again finding wz closure, but this time we are deleting, escaping this functional dependency. Then we will find the closure. We will get wz. Again we can see that the presence and absence of this functional dependency does affect our result. So this is an essential attribute, so we have to keep it. In similar ways we can find all these all the elements their functional dependency, and we have to check which element we have to essential and which element we have to remove. The same process we can apply for all. Now after doing this work we will concluded at a particular solution that the element which we can remove, we now ignore it and we cannot write again. So
एक घंटा बाइक चलावा, 1-1.5 घंटा का, तब जाके अपने आप समझ जाएगा कितना क्लियर है, अपने आप बदला है। वो एक दिन चला था।
अरे वो बात के जब मैं इसी तो काम रहता है। एक सेकंड यहाँ पे आते तो जैसे यहाँ पे तीनों जैसी आफ्टर डिकम्पोजिशन हमारे पास ये फंक्शनल डिपेंडेंसी मिला, बट यहाँ पे स्टिल देयर आर 2 एट्रीब्यूट्स विच कैन क्रिएट्स